Hello everyone, welcome to my channel. In this lecture we will discuss about the production of ethyl chloride, which is an alkyl halide. This is an example related to the production of ethyl chloride. So ethyl chloride will be produced by a gas phase reaction of HCl with ethylene over a copper chloride catalyst supported on silica is given this reaction. So 1 mole of ethylene react with 1 mole of HCl that give us 1 mole of ethyl chloride. The feed stream is composed of 50 mole percent hydrochloric acid, 48 mole percent ethene and 2 mole percent nitrogen at 100 kilomole, and the molar flow rate of the feed is 100 kilomole per hour. The temperature of the feed is 25 degrees centigrade and the pressure of the feed is 1 atmospheric pressure. Since the reaction achieve only 90 mole percent conversion, so in this reaction 90% ethylene is converted into ethyl chloride. In this reaction only 90% conversion of ethylene of ethene can be occurred. So 90% conversion, the ethyl chloride product is separate from unreacted reagent. So after the reaction we will separate the ethyl chloride from unreacted reagent. So these the after reaction some of the unreacted component will also present, so in the bottom of the reactor or in the reactor. So these unreacted component can be will consist of ethylene, hydrochloric acid, nitrogen. So these are the unreacted component, and the later is recycled. So these unreacted component will be recycled. We will recycle these unreacted component again to the reactor. The separation is achieved using distillation column. The separation the separation of ethyl chloride from the ethene, hydrochloric acid and nitrogen will be occurred in a distillation column, where it is assumed that a perfect separation is achieved. So we will assume that we will separate 100% ethyl chloride from the nitrogen, ethene and HCl. So the process is operated at atmospheric pressure and the pressure drop is ignored. So this whole process will occur at 1 atmospheric pressure, and there will be no pressure drop in the distillation column in the reactor. To prevent the accumulation of inert in the system, so to prevent the accumulation of the inert is nitrogen. So to prevent the accumulation of inert in the system, 10 kilomole per hour is withdrawn in a purge stream. So in order to minimize the accumulation or in order to prevent the accumulation of nitrogen in the system, so we will remove some of the stream, which is called purge stream, with the help of T. So now what will show the effect of flow rate of purge stream, which is W, and the recycle stream, which is R. So what will be the effect of the purge stream on the recycle stream, and what will be the effect of the purge stream on the composition of the reactor feed? So what will be the effect of the purge stream on the reactor feed? So first of all we will go to the spun HYSYS. Open the spun HYSYS, and in the component list click on add and add the component. So there are components which are ethylene or ethene. So it reacts with HCl to produce ethyl chloride. Ethyl chloride, which is ClC2. Ethyl chloride. Ethylene reacts with HCl and it produces ethyl chloride in the inert nitrogen atmosphere. So ethylene reacts with HCl and it produces ethyl chloride in the presence of inert nitrogen. Okay, now go to the fluid package and click on add. Select a fluid package. So we will use the Finn-Robinson equation of state for this case. You can also use the NRTL. So I'm using the Finn-Robinson equation of state. It shows that it is okay. Now go to the simulation and add the material stream, energy stream and the unit operation. So first of all, there is a feed which is entering to a mixer. Okay, this feed and recycle stream will mix in the mixer. After a certain time we will mix the recycle stream with this stream in a mixer. So this is the mixer. After that we will go to the reactor. So there is 90% conversion of ethylene, so we will use a conversion reactant because we have information about the conversion of reactant. So go to this and select, drag and drop the conversion reactor. This is the conversion reactor. Now after that we will go to separator to separate the ethyl chloride from the unwanted nitrogen, ethylene and other component. So we will go to the splitter. So go to the separator for separation purpose. So this is the component splitter, blank simulation, distillation column. So we will select, drag and drop the component splitter. This is the component splitter. So in the component splitter we will obtain the favor ethyl chloride in the bottom and the unwanted product will come out from the top. So after that we will use a T to separate this stream into two stream. One is the purge stream and the other will be recycle stream. It will again come to this side. So we will select, this is the mixer and this is the T. So select the T. Okay. T. Now select T and now select the, okay, now go to the recycle, select this recycle stream. This is the recycle stream. Now you can okay, now close this one and double click on feed stream. So the information about the feed stream is this is the feed to the mixer. So this is feed to mixer and it is at 25 degrees centigrade. In the question it is at 25 degrees centigrade and 1 atmospheric pressure. The molar flow rate of the feed is 100 kilomole per hour. Okay, and the composition of the feed, it consists of 48%, 50% and 2%. So ethylene is 48%, HCl is 50%, 48, HCl is 50% on mole fraction, and there is no ethyl chloride in the feed because these are the reactant. Nitrogen is 2%, is the remaining 2% is nitrogen. Okay, the sum of mole fraction is equal to 1. Click on OK. Now it is specified. So we defined the feed stream, feed number 1. This is the mixer. Click on the mixer and here rename it. So mixer, the inlet to the mixer. So select the inlet to the mixer. So this is feed, connect the feed, the mixer outlet. So mixer outlet, this is mixer outlet. Okay, now close this one. Now this feed will go to the conversion reactor. So click on conversion reactor. So the feed to the conversion reactor will be, this is the conversion reactor. Conversion reactor, rename it. The feed will be the mixer outlet and this is the reactor top. Reactor top product of the conversion reactor and the bottom product of the reactor bottom. Reactor bottom and the energy stream. So reactor energy. Reactor energy. Now it shows that require a reaction set. So we will define reaction. Okay, now this is the reactor. This is the reactor. Okay, now click on the splitter and the splitter, the inlet to the splitter is the reactor top, and this is the overhead from the splitter is splitter top, and the bottom is splitter bottom. Okay, and the splitter energy is, suppose it is splitter energy. Okay, now unknown split, so we will close this one, splitter energy. Okay, this is bottom, and the splitter is rename it is splitter. Okay, now go to the T, double click on the T, and this top will go to T, so the splitter top will go to the inlet of the T, splitter top. Okay, and the splitter outlet will be, one outlet will be the recycle, which is R, and the second outlet will be this one, purge stream. Okay, and this is T, rename it T. Okay, now now we will connect this recycle with this recycler and it will combine. So double click on recycle, and it inlet to the recycle is R, and this is the R out, recycler out, okay, out. Okay, this recycler out will be combined with mixer, second with the recycler out. Okay, so now we will rotate this compressor to okay, go to the flow sheet and rotate it 180. Okay, rotate it 90. Okay, now it is the flow sheet. So there is, now first of all go to the, this is the conversion reactor, so click on it, it is not defined, so it shows that require reaction set. So we will define the reaction for this conversion reactor. So go to the property and define reaction, click on reaction, click on add it, click on add reaction, and this is a conversion reaction. Click on add reaction, close this one, double click on reaction number 1, and the component of the reaction is ethylene react with HCl and it produce the ethyl-chloride in the presence of inert nitrogen. So the component, the stoichiometric coefficient of this will be -1, and this will be 1, because these are reactant, and this is 1 mole, 1 mole, and 1 mole of ethyl-chloride is producing. So okay, now the base component is ethylene. Okay, the phase, the reaction phase is overall. Okay, you can also change it to the gas phase, vapor phase, but like this is the vapor phase, liquid phase. Okay, so and the conversion of ethylene is how much? 90 mole percent. The reaction achieve only 90 mole percent conversion. Okay, since the reaction achieve only 90 mole percent conversion, the ethylene product is separated. Okay, 90% ethylene is converted into the ethyl chloride. Okay, so click on 90, so it is added. We have no information about C2. If you have information about C1, C2 and temperature in Kelvin and C0, you can also define your conversion percentage. Okay, click on this one and add it to the fluid package. Click on this one, it is the fluid package has been Robinson equation. Okay, click on add to fluid package. Okay, now reaction set 1. So this is reaction set 1. It is by default, it is some error, so we will okay, this is reaction number reaction set 1. We will detach from the fluid package, so it is not defined. Okay, so we will, okay, it is not defined, so we will leave it. This is reaction number 1. Reaction number 1. Okay, so click on this one and delete this reaction set 1 because we don't want. So we have reaction set 2. This is a reaction. Okay, now go to the simulation. This is the conversion reactor. Now we will go to the this is a splitter. So the splitter, it shows some error, unknown split. So we will go to the split, and here these are the component, and these are the bases are the mole, and the P to product ratio, and this is the splitter top, splitter bottom. And here if we click, this is the overhead mole fraction of ethylene, overhead mole fraction of HCl from the splitter, and the overhead mole fraction of ethyl-chloride, and overhead mole fraction of nitrogen from the splitter. So the overhead mole fraction of ethyl-chloride from the splitter should be 0, because we want that whole ethyl chloride should be present in the bottom stream, because it is given in the question that okay, the separation is achieved, distillation assume that the perfect separation is achieved. So we want perfect separation, so we want that whole the mixture which consists of ethyl chloride, nitrogen, and HCl. So we want that and ethylene, so we want that whole ethylene should be present in the bottom. It should be present in the bottom. So this shows the top overhead mole fraction on the top. So there should be no ethylene in the top. All ethylene should be present in the bottom. So I will put 0 and I will put 1 for other. Okay. Ethylene is 0 in the top, and all other components are present. Okay, overhead mole fraction. Okay, overhead mole fraction. So if you have information about the overhead mole fraction like ethylene 0.45 or some other, so you can put okay. Now we will close this one. You can also put this from the reactor outlet. You can find the fraction of the ethylene, HCl, etc. So overhead mole fraction. Okay, overhead mole fraction. So I am putting 1 and 0 for this one. Okay, now close this one and go to the T, double click on T. Okay, this is T. Okay, this is the purge stream. So the molar flow rate of the purge stream is given. That the molar flow rate of the purge stream in the T should be 10 kilomole per hour is withdrawn in purge stream. So 10 kilomole per hour. 10 kilomole per hour. Okay. Okay. Now go to this. Now go to the recycle and double click on it, and it is not solved. So we will go to the okay. We would go to the rename recycler. Go to the connection. This is connection. Go to the parameter, and here the sensitivity are 1010. This is the Okay, this is a numerical okay, this property or this one property tolerance, the variable 10 10. So I'm changing it, for example I'm changing it to 1, change it to 1 1. Okay, close this one. Now the temperature, this top temperature and the bottom temperature should be, this top and bottom temperature should be 25 degrees centigrade. This top and bottom temperature should be it is operating at 1 atmospheric pressure and 25 degrees centigrade. So I am putting this top temperature 25 degrees centigrade, 25 degrees centigrade, and this bottom is also 25 degrees centigrade, and this should be also 25 degree centigrade, 25 degree. So I will put this 25 degrees centigrade, this will be also 25, this will be 25. So 25 degree, the top is 25 degree and 1 atmospheric pressure, okay. The bottom is at also 25 degree, 25 degree and 1 atmospheric pressure, okay. Now connect, so this is the recycle, okay. Now I will this is the recycle out, so I will put some value. This, remember the composition of this speed and this speed should be same, so I will double click on the recycle, and now I will put the composition of the feed and recycle should be same. So the feed composition was ethylene was 48 and HCl is 50, there is no ethyl-chloride, and the nitrogen was 0, okay. And the temperature and other condition are also same, so I will put the temperature 25 degrees centigrade and pressure 1 atmospheric pressure, 1 atmospheric pressure, and as I am assuming 0 kilomole per hour, 0 kilomole per hour at this time. So I will change this later, but now just for running simulation, for running the simulation I am putting this one, okay. Now go to the reactor, it is not solved, so double click on the reactor and it shows a problem, the required reaction set. So go to the reaction and add the reaction, so add reaction, now it is okay. So you can see this is the reactor, and this is the splitter, this is the T. Now double click on the reactor, double click on the reactor and see the conversion. So you can see the conversion and extent of reaction. I have already defined the reaction, it is 90%, and the extent of reaction is this one, and this is 45, and the base component is ethylene, okay. You can also check some other property of the reactor, like this is the results rating, okay. You can also define the volume diameter of the reactor as you wish. This is the other worksheet, the dynamic, so the reactor vessel, etc. So okay, this is the reactor, and this is the reactor. This amount of heat is removed in the reactor. At 97.7 kilowatt energy is removed in the reactor. So this is the reactor, this amount of energy is removed in the reactor from the reactor. So this is exothermic reaction is taking place, large amount of heat is releasing from the reactor. Now this is the what is the splitter energy. So the splitter energy is and this amount of energy is removed in the splitter minus 0.156 kilowatt or 574.4 kilojoule per hour energy is removing from the splitter. Okay, this is T. Okay, now in the question it shows if we change this purge flow rate, what will be its effect on this stream? What will be its effect on this stream, the composition of this stream? So show that what will be what show the effect of flow rate of purge stream on the recycle and the composition of. Okay, if we changes this one, what will be the flow rate of this, and what will be the flow rate of this one and the composition of this stream? So okay, we assumed 0 kilomole per hour, but when we connect these streams, so it is automatically 6 kilomole per hour, 6.66. so now I'm changing this one. Suppose I'm changing the to this one to, for example, I'm changing this one to 5 kilomole per hour. The first it was 10 kilomole. Let's see, let's start. It was 10 kilomole per hour. 10 kilomole per hour. Oh, this is 6.659, about kilomole per hour. And what is the composition? So here you can check. Go to this stream, reactor feed stream, and go to the composition. Here 47% ethylene and 50% hydrochloric acid, 3% 46%, and this is about 3.12% is nitrogen, and the ethylene is 46.88%. Now change it to, suppose I'm changing it to 5 kilomole per hour. 5 kilomole per hour, enter it, and now change, see it, it is changed from 6.66 to 31 kilomole per hour, about 32 kilomole per hour. So when we decrease is this one, this will be recycle will be automatically increase, and this stream is 36. Okay, 36. Okay, and the sum of this and this will be equal to this one, which is 36. Okay, now go to the reactor feed and see the composition. At first it was 46%, now it is 40%. So you can see now I'm changing it to 2 kilomole, and the recycle is about 125 kilomole per hour, 125 kilomole per hour, and here 175. So it is, this one is increased and this is also increased, and when I decreasing this one, these two are increases. So now double click on this one and see the composition. So now it is 23%. This is decreases, this one is decreasing. When I decrease this value, this flow rate and this flow rate are increases. Okay, and this ethylene percentage is decreases, and the HCl percentage is increases, and this percentage is also 0. Okay, I'm changing it to 1. Let's check it. Now it is 271. This one is 272, and this is 320 kilomole. 271, 272, and this is okay, 272, and this is 48. So this and this when combined, it will give us this one. Okay, go to this stream, this is increase, this is 271, and this is, go to this one, go to the composition, and here it is 14%, and this is increase, slightly increase, 35%. Okay, Also check the bottom, it is 1%. The whole ethyl chloride is in the bottom because we have assumed that we want this one. Okay, this is all about the. Now you can also add the reactor. When I add the reactor volume, like double click on the reactor and the volume, suppose the geometry of the reactor, go to the rating, and suppose the volume of conversion reactor I am putting 5 meter cube, and the diameter, suppose I am putting it is calculated by spun HYSYS. The height and the diameter, the height of the reactor is this one. Okay, now what will be its effect? So now go to the liter, it is 1 kilomole per hour. Now go to the conversion and see what is the conversion. Go to the reaction and go to the results. It is 90 and 47.9. It is the reaction extent was increased. In the bottom, this is the bottom. Okay, this is the composition here. It is 11% ethylene and 49% and 3. Okay, you can also, this is the, double click on this one, and here this is the parameter. Okay, the pressure, this is calculated by spun HYSYS. The top and bottom pressure of this one is 1 atmospheric pressure. Temperature is 25. Pressure drop, this is the pressure of the column. Okay, 1 that. Double click on it. Okay, this is the variable rating worksheet, the dynamic. Okay, so this was all about that how can we recycle and how can we produce the ethyl chloride in the spun HYSYS from the ethylene and hydrochloric acid and in the inert atmospheric condition. Thank you very much for your attention. If you are new to my channel, please like and subscribe. Thank you very much.